Top 10 tractors too wide to fit on any road. They're not prototypes. They're not science fiction. Every tractor in this video was built, delivered, and put to work. But there's one thing they all share. You'll never see them on a road. Not because they're illegal, not because they're broken, but because they were never meant to leave the land they dominate. These aren't oversized by accident. They were designed that way on purpose to solve problems that standard machines couldn't touch, built for farms that stretch past the horizon, for implements that can't be pulled by anything else, for soil that destroys lesser frames. And with that scale comes a simple, unavoidable consequence. Width, not just inconvenient, disqualifying. These tractors are too wide for state lines, too heavy for bridges, too specialized for logistics. Some were hand-built, some are still in production. But none of them fit into the systems we think of as normal. Some of them broke those systems. What you're about to see is not a list of powerful tractors. It's a timeline of when engineering stopped asking what could move and started asking what needed to be moved, no matter the cost. This is top 10 tractors too wide to fit on any road, and none of these were built for compromise. Don't forget to press and hold that like button, leave a comment, and hit subscribe before we begin. Ranked 10th, Rite 750 Earthquake. One machine, no backup, too wide to repeat. It didn't come off an assembly line. It wasn't part of a product catalog. It had no successor, no warranty, and no plans for replication. The Rite 750 Earthquake was built once, by hand, by men who didn't care what a tractor was supposed to be. They weren't part of any major manufacturer. There was no boardroom, no marketing team, no regional dealer network. What they had was metal, tools, two massive Cummins KT 1150 diesel engines, and a goal to build the most potent, most unrelenting field tractor ever to run on American soil. The Earthquake wasn't born in a factory, it was born in a shop. And when it rolled out, it made no apologies. With a combined output of around 750 horsepower, a full-time articulated four-wheel drivetrain, and a chassis so wide it stretched beyond 13 feet with duals, the Earthquake wasn't merely incompatible with roads. It was physically incapable of fitting through most farm gates. There was no consideration for transport width, no effort to conform to Department of Transportation regulations. This machine was created to work a single farm in a single region for a single task. Pull the heaviest implements money could buy through the toughest soil the Midwest had to offer. The tractor was so large that it could not be moved without complete disassembly, and even then, it required specialized equipment. It was so heavy that local roads couldn't handle its load, and so wide that a standard two-lane rural road became a one-way commitment. But where it mattered, here in the field, it did the job no production tractor could. It didn't spin, it didn't stall, it didn't quit. Operators recall the roar of its twin engines like standing between two locomotives. It wasn't just loud, it was seismic. That's why they called it an earthquake. Its tires left impressions in the soil that took days to flatten. Its torque shattered conventional limits. And while it lacked the polished engineering of commercial giants like Case or Deere, what it offered was raw, unapologetic force, but force comes with limits. The Earthquake never entered mass production, not because it failed, but because it was impossible to reproduce at scale. It was too custom, too complex, and too far removed from economic feasibility. There were no spare parts, no upgrade kits, and absolutely no road it could be transported on without a whole logistical operation. Today, there is only one. It lives in Nebraska, not retired, but preserved, still operational. Still started on occasion to stretch its metal lungs. Still wider than legal, louder than regulated, and heavier than permitted. It is not remembered because it was refined. It is remembered because it dared to exist at all. In the long history of agricultural machinery, Rite 750 Earthquake is not a chapter. It's a footnote written in all caps. Proof that sometimes engineering isn't about what you should build. It's about what no one else ever will. Ranked 9th, a CO 600 Oubaas, designed in isolation, too wide for the world. No press release announced it, No film crew followed its build. And yet, in the shadow of economic sanctions and global isolation, South Africa quietly produced one of the largest tractors the world had ever seen. Not because it wanted to compete, but because it had no choice. The ACO 600 Oubaas was forged in a moment where self-reliance wasn't ideology. It was survival. At a time when the country was cut off from most international imports, including tractors, combines, and even parts for existing agricultural machinery, engineers in Pretoria and the Northern Cape were tasked with designing something that could pull more weight, work longer hours, and survive harsher conditions than anything available before. The result was not a prototype. It was a fully functional beast of industry. Powered by twin Mercedes-Benz V10 diesel engines working in tandem, the ACO 600 delivered an estimated 820 horsepower through a full-time articulated four-wheel drive system. The chassis stretched nearly 4 meters wide when equipped with its dual-tire configuration, wide enough to disqualify it from any public road in the country, even before accounting for its extreme weight and turning radius. But for the farms of South Africa's arid interior, that width wasn't a problem. It was the solution. With soil too compact for traditional tillage and thousands of hectares demanding industrial-scale cultivation, the Oubaas became more than a tractor. It became infrastructure. Unlike North American giants like the Big Bud or Case IH 620S, which evolved through decades of scaled manufacturing, the ACO 600 existed as a one-time answer to an unsolvable problem. Only a handful were ever built. One, fully restored, remains privately owned today. It's rarely moved and never driven on open roads. And why would it be? The Oubaas was never meant to travel. It was built to stay on land that swallowed lesser machines, operating day after day in brutal heat, away from dealerships, repair networks, or manufacturer support. There were no spare parts, no backup units, and no second chances. For farmers who worked with it, the machine was both a weapon and a liability. So consequential that it could rip open new fields, so large that moving it from one side of the farm to the other required entire logistics plans. But when it worked, and it usually did, nothing else could match it. In the history of agricultural engineering, the ACO 600 never became an icon. It didn't need to. It was a solution born from isolation and built too broad and too specific for the world to follow. Ranked 8th, Challenger M, T9.700, passed the limits of field and road. Where does large-scale farming end and industrial engineering begin? The Challenger M, T9.700 doesn't answer that question. It erases the line. Built not for a region, but for an agricultural philosophy that favors scale over compromise, the MT975E in dual-tire configuration is one of the most physically extreme tractors ever produced for sale. With a curb weight surpassing 25 tons and a total width of over 4.5 meters when equipped with dual wheels on all four corners, it doesn't conform to road standards, it ignores them. This machine was never intended to travel, only to operate. Powered by a massive AGCO Power 16.8-liter 512 engine delivering more than 600 horsepower, the MT975E isn't designed to impress spectators. It's designed to handle equipment the size of buildings. With full-time four-wheel drive, articulated steering, and electronic differential locking, it pulls multi-row cultivators, seeders, and rippers with ease, gliding over soil that destroys lesser rigs. But with that capability comes limitation. No paved road in any state or country can legally accommodate its full width. No overpass allows its height while loaded. No bridge built for civilian transport can absorb its axle weight. And while AGCO offers instructions for wheel removal and partial disassembly, most operators don't bother. These machines are purchased with one location in mind, and that's where they stay. The farms that use them aren't measured in acres, they're measured in square miles. And while its name may be registered under Challenger, the MT975E doesn't compete with other tractors. It competes with logistics. Farmers who operate these machines describe them not as vehicles, but as fixed assets. Land-bound power units that don't leave unless sold. Inside, the cab is functional, but not luxurious. The electronics are clean, but not distracting. There are no unnecessary touchscreens, no AI-based guidance systems, just GPS-integrated control systems and engine management that prioritizes uptime over aesthetics. This is a tool for moving earth at scale, not a toy for demonstration plots. And though it is still technically in production, few are ordered. Not because it underperforms, but because so few farms are large enough to justify its purchase. The MT975E in dual-tire form is the endpoint of wheeled agricultural machinery, not the future, the far edge of the present. It represents what happens when engineers stop designing for transit and start developing only for the task. You don't buy it because it fits your system. You build your system around it. And when it arrives, on multiple trailers, disassembled and massive, it isn't driven off the lot. It's assembled where it will live. From that moment forward, it doesn't leave because there's nowhere else for it to go. Ranked 7th, the Kirovets K-744R3. Built for fields too big for roads. Western tractors are engineered with precision, aesthetics, and refinement in mind. In Russia, the equation is different. The Kirovets K-744R3 doesn't try to look modern. It doesn't whisper luxury or innovation. It announces itself in sheet metal, welded seams, and tires that outgrow traffic lanes. Developed as a direct descendant of the Soviet K-700 series, the R3 variant takes everything that worked: simplicity, brute force, repairability, and dials it up to match 21st century scale. Powered by a YAMC V8 diesel, delivering over 420 horsepower, and often configured with dual tires on all 4 hubs. This tractor reaches operational widths well over 4.5 meters. Not as an option, as a norm. No one buys a Kirovets with road use in mind. The design assumes it will never leave the field. This is a tractor for the Russian steppe, for Ukrainian black soil, for Kazakh wheat basins. Regions where the smallest plot is larger than most towns, and where logistics mean driving in one direction for hours without seeing a fence. With articulated steering, mechanical transmission, and steel fuel tanks bolted directly onto its side rails, the K-744R3 is built for one thing only: to work. There's no suspension beyond the cab mount, no high-definition touchscreen, no complex diagnostics. Repairs are done in the open air, often with a welding torch and a manual. The dual-tire layout, while impractical for roads, is ideal for maximizing flotation across soft soils, spring mud, or frost-pitted terrain. But that comes at a cost. The machine is too wide for transport without special trailers, and even then, laws in most countries prevent it from entering public roads unless partially disassembled. That's not a problem. Kirovets tractors are expected to be delivered once, assembled on site, and remain in operation there indefinitely. Farms that use them don't cycle fleets. They commit to systems. And once a K-744R3 is on your land, you don't ask if it can go elsewhere. You build your workflow around the assumption that it will always be there, moving, towing, turning soil, regardless of season or weather. It doesn't complain. It doesn't evolve. It just works. In a world where agricultural machinery increasingly resembles digital platforms with wheels, the K-744R3 is a fossil by choice, a reminder that farming, in its most demanding form, is not about driving comfort or software updates. It's about raw land, stubborn engines, and machines that never needed a highway to do their job. The Kirovets doesn't ask where the road is. It assumes there isn't one. Ranked 6th, Fendt 167 Vario MT, too precise for pavement. Most machines on this list are too wide because they're built for brute force, but the Fendt 167 Vario MT, especially in its wide track configuration, is different. It isn't just too wide for roads, it's too advanced for them. This is precision engineering at industrial scale, a 673 horsepower dual-track tractor running on a continuously variable transmission, guided by integrated GPS correction, torque sensors, and full farm analytics. Its wide-track rubber belts, each nearly 30 inches across, bring the machine's working width to over 4 meters. That's wider than the maximum transport width allowed on most public highways, in Europe and North America. A fact that's rarely mentioned in brochures, but well known to the operators who never even attempt to take it off the field. The 1167 Vario MT wasn't built to travel. It was built to stay, to move across ultra-wide seed beds, to pull 18-meter implements without causing subsoil compaction, and to do it all while feeding performance data back into a central database. Its cab isn't just comfortable, it's digitalized. Engine RPM is managed by task load, not throttle. Steering adjusts dynamically based on terrain density. This isn't a brute machine. It's a decision engine on tracks. But that intelligence comes with consequences. The wide track variant can't navigate standard farm lanes or fit through typical equipment gates. It won't clear municipal road signs, and it exceeds the bridge load rating for most county routes. If it has to be transported, the tracks come off, and the chassis moves on a multi-axle trailer under escort. Most owners don't bother. Instead, they assign the machine to a zone and build operations around it. It works one land system, one crop type, one cycle at a time, and it excels. While older wide tractors win through metal and momentum, the Fendt wins through data and stability. It's rare to see one offline. It's even rarer to see one outside the field. There are no stories of 1,167s blocking rural intersections or taking out mailbox rows, not because it couldn't happen, but because no one ever drives them that far. They start in the field and they stay there. In a world where scale is still measured in weight and width, the Fendt 1167 Vario MT introduces a new variable: intent. This isn't overbuilt, it's overspecialized. And while the tracks make it too wide to fit into the road network, it fits perfectly into the future of agriculture. A future where the machine no longer adapts to the environment, but where the environment is modeled around the machine. Ranked 5th, versatile 620 DT, built for ground that shouldn't be farmed. Not all oversized machines wear the badges of fame. Some are built quietly, far from the spotlight, away from sponsorship deals and innovation expos. But for the people who manage tens of thousands of acres, where the soil sinks underfoot and winter doesn't wait, recognition doesn't matter. Function does. And in that world, one name keeps appearing on invoices for machines too wide to move, too heavy to turn, and too committed ever to leave the field. Versatile 620 DT. This isn't a luxury flagship. There's no digital display to impress visitors, no European design to photograph. What you get is a machine with one agenda: move more ground, with less slip, in worse conditions, over longer hours. And make no excuses about comfort or legal width restrictions. The versatile 620. DeltaTrac was born for places where no one cares if your tractor fits down a road because there is no road. The specifications alone push past conventional categories. An operating weight over 27 metric tons, a Cummins QSX-15 engine that puts out 620 continuous horsepower without digital throttling or multi-mode eco limits. 4 independent rubber DeltaTracs, each distributing the load with flotation optimized for spring thaw or saline subsoil. The frame is fully welded. No hinge, no articulation, no modular convenience. It was designed not for flexibility, but for permanence. And that permanence comes at a price. With a total width pushing 3.9 meters, it surpasses legal road limits in nearly every country that has a Department of Transportation. Standard highway lanes in North America measure 12 feet. This machine crosses that boundary while parked. Suppose you need to move it from one field to another across counties. In that case, the procedure involves removing the cab roof, detaching the track assemblies, and loading it onto a multi-axle transport unit rated for extreme loads. This is not transport, it's controlled migration. Yet among large-scale farms in Manitoba, Saskatchewan, and the American Upper Midwest, the 620 DT isn't a monster, it's a necessity. These aren't machines that go to work occasionally. They start before dawn, run for 14 hours straight, and repeat the process for weeks. They till saline zones that rip lugs off radial tires. They work in black soil so sticky that it stalls lesser machines. And they don't need to be agile. They need to finish. Versatile didn't build this machine to win awards. The company doesn't dominate the market share. It doesn't sponsor racing events or reality shows about farming. But what it does understand, better than most, is that some land doesn't accept compromise. And for that land, a 27-ton, 4-track, 620 horsepower rectangle of steel and hydraulic control is the only acceptable answer. There's a reason you'll rarely see a 620 DT in traffic. It isn't banned. It isn't restricted. It's simply incompatible. Like a ship built too wide for its harbor, this tractor doesn't belong on roads. It never needed to. Ranked 4th, New Holland T9.700. The last tractor before transport becomes impossible. The New Holland T9.700 sits at the edge of what's possible and what's still legal. It is, by design, the largest wheeled agricultural tractor in the company's lineup, and one of the last machines of its class that can, on paper, still be classified for road use, but few owners even try. With a 682 horsepower FPT cursor, 16-liter engine under the hood, and a curb weight exceeding 25 metric tons, the T9.700 isn't just large, it's scalable. Built on an ultra-wide frame platform that accepts duals, triples, or flotation tires, its maximum working width can stretch past 4.6 meters, depending on configuration. That puts it squarely in violation of transport law across every American state, Canadian province, or European nation. But the T9.700 isn't made for the highway. It's made for farms that operate more like logistical zones than fields. In places like Saskatchewan, the upper Midwest, or inland Australia, operators don't drive this tractor to work. They live with it. They design field maps around it. And once it's in position, it stays. Even if the factory documentation includes road lighting kits and transport warnings, the reality is simpler. No one buys the T9.700 expecting it to move between jobs. Its job is in the field. With a 16-speed complete power shift transmission, 4-wheel articulation, and ballast capacity that rivals track machines, the T9.700 pulls 20-meter implements without strain. Its torque rating allows for maximum load under suboptimal soil, and its wheel options allow growers to fine-tune contact pressure down to fractions of an inch. But all of that comes at a cost. Bulk. Moving this tractor legally requires detiring and loading onto extended flatbeds. Even with just duals, it can't safely cross bridges built for civilian trucks. And yet it doesn't matter, because in the world where this machine operates, distance isn't measured in miles. It's measured in hectares. Comfort in the cab rivals long-haul trucks. Visibility is panoramic, and the onboard guidance systems link seamlessly to precision ag software. It is not a brute, it is a platform. But a platform whose physical dimensions have quietly crossed the line from transportable to permanent. There are larger tractors, there are more powerful ones. But the T9.700 may be the last one of its kind. A wheeled machine that stretches the definition of mobility without ever officially surrendering it. Once delivered, it rarely moves again, and no one asks it to. Ranked 3rd, Case IH Quadtrac 620. Too strong to share the road. What happens when a tractor becomes too powerful to move itself legally? The Case IH Steiger. Quadtrac 620 doesn't ask that question, it proves it. With nearly 700 horsepower, 4 independent rubber tracks, and a working width that exceeds 4.5 meters in wide track configurations, the 620 isn't just one of the strongest production tractors in history. It's one of the least mobile. But that's by design. Developed as the flagship of Case IH's high horsepower lineup, the Quadtrac 620 was never meant to rotate between fields on back roads or pass under power lines. It was made for a single purpose: to dominate land, wide, heavy, unforgiving land, at a scale most machines can't comprehend. At the heart of the 620 is an FPT Cursor 13 engine, capable of maintaining torque under massive drawbar loads without RPM drop. That engine feeds power through a fully articulated frame to 4 rubber tracks, each working independently to maintain contact across rutted, frozen, or wet soil. The result is traction without compromise. No wheel slip, no rutting, no downtime. But that same system, when measured by road authorities, becomes a problem. The Quadtrac 620, when configured with 36-inch wide tracks, stretches beyond any USDOT transport limit. Bridges can't support their axle load. Guardrails aren't spaced wide enough to admit it. Even state roads in ag-heavy counties issue warnings for their movement. So it stays. From the moment it's delivered, usually in pieces, the 620 is assembled once and expected to remain on site for its entire working life. There are farms in North Dakota where it has never left a 5-mile radius, but in that radius, it is king. Pulling 80-foot air drills, subsoilers the size of shipping containers, and strip-till units built for another generation of farm size. Inside the cab, operators sit above traditional tractor eye level, viewing touchscreen diagnostics, live soil feedback, and onboard diagnostics that feed into full farm data clouds. Yet for all its tech, its mobility is still limited by physics. No matter how well it drives, it simply doesn't fit anywhere but the land it owns. Farmers who run Quadtrac 6.2s don't call them tractors. They call them infrastructure. Because these machines don't rotate in and out of duty, they define the system itself. And the road? It's not part of the plan. It never was. Ranked second, John Deere 9.600RX. Engineered for precision, too wide for return. The John Deere 9.600RX wasn't built to wait. It was built to act. Immediately, continuously, and irreversibly. Designed as the most powerful tracked tractor in the company's history, the 9.600RX in dual-track, wide-spacing configuration represents the end of flexibility in favor of complete, dedicated performance. With nearly 670 horsepower generated by a 15-liter Cummins QSX-15 engine and delivered through Deere's E18 PowerShift transmission, this machine does not hesitate, it commands. But with that command comes a physical price: width. Equipped with dual high-flotation rubber tracks, spaced for maximum weight distribution and minimal soil compaction, the 9.600RX reaches an operating width of over 4.4 meters, wide enough to disqualify it from road transport in every jurisdiction without disassembly. This isn't a temporary compromise, it's a permanent condition. The moment this machine is delivered and assembled, its movement ends. Because it was never designed to relocate, it was intended to control. In the high acreage grain systems of the American Midwest, in the dry lands of Western Australia, in the long, flat production zones of Saskatchewan, the 9.600RX lives where it works. It pulls equipment that few other machines can even lift, including 24-meter seeders, deep-till cultivators, and multi-tank fertilizer systems. Its operator sits in a sealed, stabilized cab, viewing not a dashboard, but a mission terminal. Live implement feedback, zone-based soil response, precision GPS layering, and active traction balancing. But even as the systems grow smarter, the machine grows less mobile. Tracks that optimize field operation destroy asphalt, axle weights designed for tillage-damaged bridges, and the width, even at its most compressed, crosses beyond legal boundaries. So the machine stays, and everything else adapts around it. Supply trailers are scheduled to meet it. Implements are configured for their spacing. Farm infrastructure is redesigned to accommodate its turn radius. The 9.600RX doesn't integrate into an existing operation. It transforms it. And while John Deere offers narrower, more road-friendly options, this configuration is selected for one reason: permanence. For operations that demand relentless output over transportability, for land that cannot afford inefficiency, the 9.600RX becomes a static power source, a fixed solution to a moving problem. You don't rotate it between farms, you build the farm around it. That's the point. And in that reality, width isn't an inconvenience, it's a declaration. In first place, Big Bud 16 V747, the machine that ended the race for size. There's no debate. There's no alternate version. There is only one. The Big Bud 16 V747 is the largest farm tractor ever built and the most physically dominant piece of agricultural machinery to have ever touched a cultivated field. Nothing before it came close. Nothing after it tried. Constructed in 1977 by Northern Manufacturing Company in Havre, Montana, the 747 was a single-unit commission for the Rossi brothers, who needed a tractor capable of pulling a 30-meter wide air drill across their California cotton operation. The engineers delivered a machine that rewrote every rule, a 16-cylinder Detroit Diesel 5, 92 engine pushing between 1,100 and 1,200 horsepower. A 6-speed transmission drives all 4 wheels through custom-built axles, an operating weight of over 45 metric tons, and a working width, when equipped with complete dual wheels, of more than 7.7 meters. That number alone makes it ineligible for every road, bridge, or rail crossing in the world. Not just by regulation, by physics. Moving the 747 off-field requires disassembly, not partial, full. The cab, engine housing, tires, ballast, and frame are all separated, shipped independently, and rebuilt on arrival. The original buyers knew this, so did the manufacturers, but no one cared, because the 747 wasn't meant to be moved. It was built to stay, to pull 80-foot cultivators through land so broad and so flat that the horizon was the only thing it couldn't reach. When operating, the machine doesn't drive, it occupies. The soil behind it compresses under its weight for days. The implements it pulls don't just disturb the surface, they reset it. And inside the cab, there's no pretension of luxury. Just switches, gauges, power. In the 4 decades since its creation, no manufacturer has attempted to build something larger. Not because the design is lost, but because the justification is gone. No modern road system allows for its transport. No manufacturer carries liability insurance for its size. No engineer can argue for its efficiency. But none of that matters, because the 16 V747 was never built to make sense. It was built to prove that if you remove every constraint, budget, regulation, dimension, you can create a machine that ends the discussion. And so far it has. There are more powerful machines. There are faster ones. There are smarter ones. But there is only one that stands at the outermost edge of what a tractor can be before it stops being a tractor altogether. Big Bud 16 V747 is not a concept. It's not a legend. It's real, it's still running, and it still doesn't fit on any road. Every machine on this list was built to solve a problem. But in solving it, they created a new one. They no longer fit into the systems that surround them. Too wide for roads, too heavy for bridges, too permanent for movement. And yet, not one of them failed. Many are still in use. What changed wasn't the machine. It was everything else. The infrastructure, the laws, the expectations of mobility. These tractors were never meant to adapt to the world. The world was meant to adapt to them. And for a handful of farms across the globe, that's precisely what happened. Buildings were spaced wider, transport routes were redrawn, field plans were rewritten. Because when a machine exceeds every standard and still delivers, you don't move it, you build around it. That's not scale, that's commitment. And for these 10 tractors, that commitment begins at the edge of the field and ends nowhere near a road. Let us know which one resonates with you in the comments, and don't forget to like and subscribe to our channel for more content like this.